So today we are starting Unit 2 in Maths in Year 8, and we're looking at index notation. A little reminder before we start about the commutative and associative laws. Now the commutative law says that order doesn't matter. So if we have two numbers that we're adding together, A and B, we can add A to B or we can add B to A. The order doesn't matter. This is the same for multiplication. But this law only works for addition and multiplication, not with minusing and not with dividing. The associative law then is very similar in that it also only works for addition and multiplication and not subtraction or division. And this is where we can group different numbers together as a mental strategy to make calculations easier. So if you had a string of numbers that were added or multiplied together, you could group those numbers. So here we've grouped A and B and added the result of that to C. Here we've grouped B and C and added the result of that to A. So again, this is a mental strategy to make calculations seem simpler and more approachable. We're also going to recap a little bit of index notation. There is a link between addition and multiplication and a reason why these laws work for both addition and multiplication. Another way of writing a repeated addition, so for example if we had 10 plus 10 plus 10 plus 10, we could write that as saying we had 4 lots of 10. So an equivalent way of writing that is 4 times 10. So multiplication is basically a repeated addition. There's a link there. And we can make this link algebraically as well. So if we had 4 lots of x, all right, written out like this, we could simplify that and write it as a notation of 4 times x, which is 4x in algebra. Remember, we don't need that times sign all the time. So index notation then applies for when we are timesing lots of numbers over and over again by themselves. So for example, if we had 10 times 10 times 10 this time, all right, we've still got 4 tens, but this time instead of being added together, they are being multiplied by each other. And this is where we write index notation. So instead of saying we have 4 lots of 10 to work with, we now have 10 to the power 4. So our base is 10, that's the number or the quantity that's being timesed again and again and again by itself, and we know that this process is happening 4 times. So over here we've got the base and the index. Alright, and this whole expression is called a power. So we have the base, the index, and the whole thing is called a power. And we say this as 10 to the power 4. And it means 10 multiplied by itself 4 times. Now the answer to this sum is not 40. We are not doing 10 times 4. We are doing 10 times 10 times 10 times 10. All right, so the number is a lot bigger. 10 times 10 is 100, times 10 is 1,000, times 10 again is 10,000. All right, not 40. To put this in an algebraic example, we can have x times x times x times x, and this time we would just write x to the power 4. All right, so remember we've got our base, which is x. That's the number being multiplied by itself, or the quantity being multiplied by itself, and there are 4 of them, so we write to the power 4. And both this and this are examples of simplification, which you've seen in algebra. When we have equations or expressions that are long and cumbersome, we can simplify them down into a more concise notation. So we've used multiplication here to tidy up repeated addition. We've used index notation here to tidy up repeated multiplication. You need to be able to work with this concept forwards and backwards. All right, so we've done the forwards way. We've got a long string of repeated multiplications and we've tidied them up into index notation. But you may well get asked, and you may well need to when you're actually calculating or trying to solve an equation using index notation, you will have to go backwards and go from index notation back to the repeated multiplication. So let's say we had 3 to the power 4. All right, and you were asked to put this back into the repeated multiplication. You know that our base is 3 and our index is 4. So the base is what we're timesing by itself every time. All right, and we're going to do that 4 times. So we should have 3 times 3 times 3 times 3.